This renovation, like all others presented on our channel, is supervised by the Austrian Institute of Building Security.
Hello and welcome. Today's video will present the removal of damage caused by moisture migration. And we will also show you how we started to counteract it. The recurrence of its effects in the basements and ground floor of a large building in the city of Zakopane. The building is called Residence Polenia. We started the work by conducting an expert analysis, which revealed that all the building's moisture protection measures from the very beginning failed, and therefore it was necessary to simply apply a completely different method and in fact create a true waterproofing in that building. For many years, the building was under the influence of intense and, importantly, recurring groundwater impact. This process led to the systematic penetration of moisture into the structure of the walls, more so in the ground-level areas and basements. The result was not only periodic flooding of the underground rooms reaching up to a height of 60 centimeters, so you can imagine how serious the damage was. Also prolonged dampness of building partitions and consequently the degradation of their mechanical and insulating properties, as well as the activation of destructive physico-chemical processes. Here we mean mold growth. The main cause of the discussed problems was the originally faulty installation of moisture insulation during the construction of the building. Particularly unfavorable conditions prevailed around the internal stairs, where improperly constructed formwork created spaces for direct water inflow. The actual level of groundwater in this area is not known, however, based on technical observations and analysis of the height of the originally applied bituminous insulation. It was done up to a height of 150-160 centimeters in some places from the floor. It can be maintained that the groundwater level remains relatively high. This indicates the possibility of vertical water impact on the entire height of the wall, which exacerbates the problem of moisture migration and the difficulty in stopping it in a pinpoint or linear manner. And interestingly, in subsequent years, ad hoc attempts were made to solve the moisture problem using readily available bituminous materials. In many places, proper substrate preparation was not ensured, leveling, dust removal and drying were neglected, and moisture parameters exceeded the permissible technological standards for waterproofing works. As a result, the insulation showed a lack of continuity, incomplete adhesion to the substrate and variable thickness. Particularly critical were the areas where walls connected with foundations, which were completely overlooked during the initial protection stage. The applied waterproofing measures lacked the ability to permanently bond with damp concrete and masonry, leading to their degradation already during the operational phase. The final stage of these repair attempts was the application of a dedicated waterproof concrete screed of class C25, C30 with a thickness of 16-20 centimeters. Although the material itself is characterized by good tightness, it was not properly bonded with the wall structure. This screed only served to protect the floor, not covering the critical junctions of the walls with the foundation. Moreover, old layers of bituminous insulation and plaster were left under its surface, which still allowed moisture retention and its further migration into the interior of the building. To permanently solve the problem of moisture migration and lack of tightness in the ground level area, we used MCT technology, a system of mineral sealing materials operating on the principle of crystallization reaction and activation in the presence of moisture. Primarily for repair, we opted out of commonly used injections in favor of effective horizontal channel insulation. Simply put, injections should not be done in basements as they further weaken the wall. We carried out the work according to the following technological process. First, the removal of ineffective coatings, manual and mechanical removal of old bituminous layers, consolidated plasters, and contaminants down to the level of active substrate material, in this case, the mineral base wall. Surface preparation. We thoroughly cleaned mechanically, removed dust, and checked the moisture level. We prepared the surface to a matte damp state, in accordance with the application requirements of crystallizing materials. We also sealed critical areas at the wall-to-foundation connections and performed strip sealing at a height of 30 to 40 centimeters. We used the NCT semi-crystalline system mortar and the NCT crystal surface activator for this. The MCT system was applied in layers, using a two-step process with MCT crystal materials, which first contains active components that react with water and calcium hydroxides. This leads to the formation of insoluble silica crystals that close the micropores and capillaries in the masonry structure. Next, MCT Chem is a mineral sealing mortar with high resistance to negative pressure, enriched with additives that strengthen internal bonds. These additives also reduce permeability. And finally, the maintenance and activation of the system for a minimum period of 72 hours. We maintained controlled surface humidity, ensuring full activation of the crystallization mechanism and bonding of the structure. This structure, it should be added, will continuously strengthen due to the applied mortars, will keep hardening, sealing itself, and thanks to this, we can provide a minimum 30-year guarantee of dry walls and floors, as well as being free from fungi and mold. If you enjoyed today's video, give it a thumbs up and subscribe to our channel for more information on modern systems for drying buildings affected by moisture and mold.
If you enjoyed the video, leave a thumbs up and subscribe to our channel for more construction tips. Thank you for watching and see you in the next project.